Okay, so if the cable car is going up at a constant speed, then we know that acceleration is 0, so net force should be 0. So net force is 0 means that the downward weight is exactly balanced by the upward normal contact force. This is of course the contact force that the floor exerts on the passenger's foot. What if the cable car is actually accelerating up the slope? So now we got the acceleration of the cable car. If the passenger keeps up with the cable car, then of course the passenger will also be having the exact same acceleration in this direction. That means the passenger require a net force that's upward and rightward. The upward net force is provided by the normal contact force becoming larger than the weight. But what about the rightward net force? The only thing that can push this man rightward is the floor. So that means there's going to be a frictional force to the right. Okay, so there you have it. The upward net force is provided by the normal contact force being larger than the weight, and the rightward net force is provided by the frictional force. Many students cannot understand why there should be a rightward frictional force of the floor on the passenger. So let me quickly explain that. You got to remember that friction comes about when there's a tendency for relative motion between two surfaces. So this is the foot of the passenger and this is the floor surface. If the floor and the passenger are going at a constant speed, the same speed, then there's no tendency for relative motion, so there's no friction. But if the floor is accelerating to the right, if the floor doesn't exert any frictional force on the foot, then the floor is going to be traveling faster than the foot. So there's now a tendency for relative motion. It's the tendency for the foot to slide backward relative to the floor. Get it? Because the floor is accelerating to the right, whereas the foot just want to maintain its constant speed, right? So the foot is going faster than the foot. So there's a tendency for relative motion, which is the tendency for the foot to fall behind relative to the floor. So what will the floor do? It will exert the frictional force in a forward direction because it wants to oppose this tendency for relative motion. It wants to prevent this slipping of these two surfaces. Okay, so I hope I've made everything clear. That's all. Ta-ta!